Odoo security. We'll have a 50-minute session, and at the end, we'll have a short question and answer talk where you can ask your questions. You can ask them right now in the chat next to the video. My name is Olivier Denis, and I'm a security engineer at Odoo. I've been working here for more than 10 years now. And every day at Odoo Experience, I like to make a presentation about security. This one could be titled Odoo Security Introduction. I think it is very important. Obviously, security is a very important topic. We see that every day in the news, the data breaches that are all over the place and the reputation damage that can bring to the companies who suffer them. But software security is also a very hard topic. And why is it hard, actually? How hard is it compared to different engineering problems, such as building bridges? Building a bridge is something that engineers have been doing for a while, and they know that it is a complicated job. They have to take into account a lot of physical challenges that the bridge is going to face. They have to take into account the natural challenges, like earthquakes that could happen, hurricanes that could happen in the area. Then, of course, they have to design the bridge to support its own weight and the weight of all the vehicles that are going to pass over it. And then it has to take into account also some accidents, some man-made challenges, such as, let's say, a truck carrying acid passing over the bridge and crashing, spilling all of its load over the bridge and damaging the structure. Those are all the kind of challenges, difficult challenges that a bridge has to be able to withstand. But engineers constructing bridges know about these challenges. They have a list of all the possible problems, and they also know the likelihood of those problems, the frequency of hurricanes and earthquakes in the area where that specific bridge is being built. And if there is an accident, like a truck of acid spilling over the bridge, they know that there will be a maintenance being carried on the bridge. It will be repaired before continuing operations. Software security is a bit different. There are, of course, a number of well-known challenges that your software is supposed to address. But then there is an infinite number of possible challenges that attackers are going to send to your software. They are going to look for even the less likely problems that your software may not have been designed to address. If there's a problem that is even remotely possible, they are going to trigger it. And if there are several possible problems, they are going to trigger them at the same time or combine them to get a worse effect on your system. It's a bit as if nature itself was trying to bring down your bridge. It was waiting for a truck to pass and then sending earthquakes and hurricanes and combining the effects of all of these challenges to take down your bridge. Obviously, we would have less bridges standing still in the world if that was the case and nature was trying to intentionally take down your bridges. So in software security, intent changes the odds. And what can you do facing those challenges? If your attackers are inventing new challenges every time, how can you fight against this? Well, there's no silver bullet. You have to think like an attacker. You have to imagine that you are looking for problems in your software and you are actively trying to take it down, to break it. And it's something that is difficult for engineers to do because naturally your bias as an engineer is to make things work. You are looking at likely cases that you want to address. You're not actively trying to break the things that you're building, right? So in order to do that, software security engineers have to use knowledge and mindset. Those are the key factors that are necessary for protecting your software when you are designing it. So during this talk, I will try to give you a bit of knowledge and some hints as to the right mindset that developer can adopt in order to protect the software that they're creating. At the end, we'll have a review checklist that you can use when you are developing and ready to ship a feature or merge the source code that it corresponds to. But before, I'll have a short recap of one thing that has common misconceptions and something that you cannot defend the software if you don't know. And this is the security model of the software you're trying to defend. Odoo has a very specific security model with different layers of protection around the data access layer itself. Odoo uses a role-based access control model with groups that are granted to users and define the kind of access they have over the different types of data in the system. There are common misconceptions with this because people sometimes think that the security is also built on the client side and that the views and menus that you see actually define the security of the data, and that's not exactly so. If you are discovering this topic, you may want to have a look at my past presentation in previous versions of Odoo Experience, where I'm going over this topic a little bit into more details. So let's move on to what are the risks, what are the well-known areas that you should plan for when designing your software and trying to defend against it. And for this, I like to use what is called the OWASP Top 10 list. OWASP is a very nice community-driven project. It stands for Open Web Application Security Project. And they are doing a very good job of collecting statistics and data about all of the software security issues that modern web applications contain. It's community-driven, so it uses data that comes from vendors, from researchers, from users of software, and they are updating their documentation, their knowledge base all the time. So it's a very interesting resource for developers and security researchers. The top 10 is the most well-known publication. It's reviewed every few years in order to include the latest trends in software and security issues. Here you can see the issues listed from A1 to A10. These are the most frequently found issues in software. Generally, those are very broad classes of issues. So we'll have a quick discussion over each of these classes and see how they apply in the context of Odoo. But first, you're not alone in fighting those issues. Obviously, Odoo has taken into account all of these possible challenges, and the framework itself is designed to be able to resist and avoid the most frequent mistakes that could lead to those issues. But that's just a tool, right? It's just a framework. And as we've seen, attackers are actively trying to break it. They're going to intentionally look for issues in your software. So the framework cannot be the only answer. You need the right knowledge of all the problems that the software could carry, all the technologies, all the protocols that will be involved in using your web application. And you need the mindset of actively stopping and thinking, oh, now that I've built this feature, how could someone try to break it? And we'll see that this takes some non-natural steps during the development cycles. So let's go over the first topic, A1, injection. Injection is probably the best known type of software security vulnerability. And basically comes when some data provided by a user, some untrusted data, is somehow interpreted as code and becomes executable. Obviously, the best known type of injection is probably SQL injection, a very famous type of issue that has been around for decades. But maybe we can discuss it in the context of Odoo and see how that could possibly happen despite having a framework trying to protect you from it. Here's a famous example of SQL injection context. You may be familiar with this XKCD comic where there is a student whose name is supposedly Robert, quote, closing brace, and then drop table student. This is a typical example of what a SQL injection might look like. So how would that work? Let's say we have this piece of code in a method from Odoo. Of course, we're going to have a few pieces of code here. It's a rather technical presentation. So here we have a method with a few interesting things to note. if you look at it, you see that the method is constructing a query that is going to be sent to the database. The query is constructing with manual SQL code, and we see that there are two variables that are inserted into this query. We have the name and we have the partner type that are actually parameters that the method takes when you call it. The problem comes from these parameters being directly injected. Remember, this is the name of the vulnerability, injected into the query, and the query is a command, is a code that is sent to the database for execution. The problem here, if you imagine that the name variable that you see in the method here actually comes from the name of this student, Robert, but his name ends with, you know, this weird sequence of characters. What will happen if you insert this in the query that we are building? We have a select here, so there's going to be select from partner where name I like. There's a beginning quote, and the ending, the name of the student here, Robert, will actually close the quote, then terminate the first instruction, and the next instruction, drop table student, will be executed. So what happens is we've mixed data and code together, and we are going to face the consequence that some unforeseen code will be executed over our database, and in this case that could lead to dropping tables or actually arbitrary changes to the database, the underlying database. So obviously that's a gigantic security breach in your application. How would you do this correctly if you wanted to avoid the issue? Assuming that you still want to do something with a manual SQL query. Obviously, we have solutions in the framework, in the ORM, that would address this in a more clean manner, and we'll see how just in a few minutes. But let's assume that for performance reasons or other reasons you need a SQL query here. Maybe it's going to look a bit more complicated than what we have here. This is a simplified example. What you could do is to know how to use the API and know that the execute method that we see at the end of the method here supports a set of parameters that is going to inject into your query, but is going to do that in a safe manner. It knows the special characters that have to be escaped within a SQL query, so in order to avoid SQL injection and unwanted execution of code. But that only takes care of the first issue, the name of the student, that becomes a parameter and is then safe. But we still have another parameter called partner type here. And partner type actually stands for the name of a column in the database. We can't pass that to as a parameter to execute, because it's going to quote it as data, and that's not going to work as a column name in the query. So what could you do? Well, here there's no predefined solution here. You have to come up with some way of securing your code here. One example of doing that would be to introduce an explicit test here, where we are going to verify the value of partner type that we have been given and verify that it can only be one of the two expected values that we want to address here, and then raise an error if that's not the case. If you look at this change, it's something that is absolutely not necessary in order to implement the feature. It's code that you need to explicitly place there to defend against attackers that would want to break your system. So that's where the mindset comes up, and you always need to think about all of these issues. Now, obviously, as I was saying, a proper way of doing this would be to use the ORM, and this is one example here, where we have used the API directly. We pass the name and the partner type as parameters to the search method of the ORM, and it's going to do everything for us. It's going to escape special characters that would be dangerous, and it does even take care of verifying the partner type and column names and making sure that these actually exist in the database and are valid column names here. So that would be obviously the right way of doing it. Let's go over and continue with the next one, our top two, broken authentication. That's actually a broad area of issues that could come when you are implementing some sort of session management, starting with the authentication of users when they log in, log out, but also all of the things that are incidental to that session management, the time when you need to disconnect user, when they are deactivated, and so many things. So the bad news is that this is actually very complicated to get right. There are tons of small, silly mistakes that you can do that can have dire consequences in the proper security of your sessions. But the good news is all of these difficult things to do that are listed here on the right are solved for you by Odoo. The system already takes care of doing all of that properly, of securing the cookies that are used for the session, of properly handling the security of the password, of preventing brute force attacks. So there are a lot of small things that are done for you by the system. So normally you would never need to do any of that. But if you are implementing your own session security, if you want to implement some third-party authentication system, then you have to be careful and you have to take all of these things into account. In that case, you would certainly do right in having a look at the documentation from the OWASP project for this A2 item and look at all the challenges that you have to defend against. And by the way, every version of Odoo improves in terms of session management according to the latest evolution of the technologies and the protocols. And this version, Odoo 14, comes with an interesting feature, multi-factor authentication, where user can use an authenticator application as a second factor after logging into the system. Moving on, we are going to have a look at item number 3, sensitive data exposure. This is a broad area, again, of issues that could happen when any kind of sensitive data is insufficiently protected. Sensitive data can be passwords, credit card numbers, but also, sensitive data, personal data, which is a very important topic now with the new data protection regulations occurring everywhere in the world. What would this look like in Odoo? Let's have a quick example here. We have two definitions of employee classes here on the screen. The top one defines, as you can see, two fields for employees. We are going to have a field for social security number and one for the password number of the employee. So naturally, you would define them like that and store them on the employee record. But then if you remember the security model, you know that employees are records that are visible to other employees, because obviously an employee directory is something useful in a company, so you want employees to be able to look up the names of other employees in the company. But if they have access to other employees, they also have access to all the fields, and specifically this social security number or the password number of the employee. And that comes as a problem, because those are sensitive pieces of data that only maybe HR officers should be able to look at, but not other employees. So that's where you would use one of the features for access control in Odoo. And the second example below uses that, a group restriction set on those fields in order to make sure that even though employee records are visible to all other employees, these particular fields will only be available, displayed, but also even through the API or the RPC access, they will be off limits for normal employees that do not have, in this case, the HR officer group. And remember, importantly, the best protection for data is not to store it. If you have a way of not storing data, it's best not to do it. Typically, credit card numbers, you should not touch them if there is a way to delegate that to an entity that is properly PCI compliant, all the drill with credit card number issues. That's, of course, the best way to do it. Next item is XML External Entities. That's a weird thing. XML documents are unfortunately something that many applications have to deal with. And whenever you deal with an XML document, the first thing you have to do is to parse it and extract, in order to extract the data from there. It turns out that the XML specification standard has a lot of very obscure features that you may not need to use, but introduce very advanced systems that can lead to problems if they are misused. The good news, once again, is that the framework does most of that work for you in order to avoid those pitfalls with XML parsing. In order to do that, we use the LXML E3 API for parsing XML documents. And if you are using that as well, then you are on the safe side. But if you are doing some sort of specific XML parsing, like you have to parse gigantic documents and you need a SAX parser, a different kind of API for parsing XML, then you may face those challenges. And then you have to look at maybe the diffused XML Python library that takes care of configuring different XML parsers in order to avoid all of these well-known problems. Some of them are depicted on the right here. We have recursion bombs where using external entities, which is why the problem is called XML External Entities Issues. You can define recursive entities that are going to be recursively defined over other entities, leading to enormous amount of data when the entities are resolved in the memory of the parser. Typically, a small document with like 10 lines could expand to gigabytes of data in the memory of the system, and obviously lead to denial of service or taking down your system or making it very slow. Just again, an example at the bottom is when you would try to make an entity correspond to a local file taken on the server itself. And if the parser doesn't protect against that, there's a chance that this local file will be accessed by the parser and put back into the XML document. And if that document ever goes back to the attacker, they will be able to exfiltrate data that is normally local to your server, another really important security breach. But normally you're safe if you're just using the framework as intended. And we're going over one of the biggest issues that we are facing with Odoo, broken access control. This is one of the top two Odoo security issues. The other ones are less common in Odoo code, but as part of my job as a security engineer, we are reviewing the work of our colleagues all the time at Odoo and sometimes also external code. And broken access control is one of the top two issues that we face when reviewing source code. Broken access control, as the name indicates, happens when the access control rules that you have designed in your security model are broken and not properly enforced by your code, or attackers have a way to circumvent them. How can that happen with Odoo? Well, the most obvious way it can happen is by failing to define these access control rules in the first place. As part of the development of a new app, a developer will normally specify a list of access control rules like create, read, update, and delete permissions that are granted to different user groups in the system. But sometimes we see the examples we have here on the top right, where the access control was full access all once, as you can see here on the slide, but granted to no group, which means to everybody in the system. And that's not something that you want, because it means not only just all the employees, all the users, but also external users, customers, visitors, may be able to access that piece of data. Definitely that's not something that you want. But even the next example, the middle one, where the employees are given full access, is something that you don't necessarily want, unless you have another rule, a record rule, as we call that, a record rule where you filter the employee, the data that is visible to the users, and make it so that users can only see their own records, because there is a field that identifies the owner of that record. In that case, it may be okay to have full access for an employee. But normally what you want is what we have here on the bottom right, is several rules for the different groups, and normally the normal employees have just a limited access, like possibly read access only, and the manager group has full access, and most importantly the portal and external groups have no access at all. And by the way, something is changing in version 14 regarding ACL definitions, is that now we are requiring transient models, so the data models that are used for wizards and temporary widgets in the system, also now require explicit access control definitions. They used to have some implicit ones, but we felt that it wasn't giving sufficient granularity in terms of defining the access control. So now we want them to be explicit. The next example of an issue that you could face in Odoo is when you are writing controller routes. Here is an example where you see a sale controller route. We see /sale, /order ID, where there's going to be an actual ID of order, /approve. We see the type, the methods, and the authentication method that is activated for that route. So typically, this controller could be used when you are sending the user to a preview of their sale order. They receive the link by email, and they're viewing the sales order, and they have an approve button where they can give their approval for the sales order. This is what the controller may look like. And for the purpose of being able to display this to the user when they are not authenticated, because we don't want them to have to go and look for their password because they always lose them, we are going to have a route here that is set to the authentication method public, because visitors are not authenticated at that point. The problem, obviously, is that the public user has no access over sales order. There's no sale order that belongs to the public user. So how are we going to solve the fact that the sales order needs to be approved by someone? The normal way to do that here, or the natural way that developers might want to use here, is to use sudo in order to go into the privilege, the super user mode, and perform the operation. The problem here may be obvious. There is nothing guaranteeing that no attacker will be calling this route, this URL, with arbitrary sales order, and if that happens, we have no control over the kind of sale order that we want to approve, and no verification of the identity of the person trying to approve them. So if we did that, we would have a broken access control issue, because anybody can approve any sales order. So how do we control that? There would be different options. One would be to switch to authentication user, requiring the user to log in, and then we would remove the sudo and allow the normal ACL system to operate. But if we still want to have the public viewing of sales order and the approval button there, we can use the same thing that we are using to grant access to the sales order, and that is using a token to verify that the visitor knows a secret about the sales order, which proves their identity, because only them received that token by email. So we are going to take an extra token parameter. We are going to verify it before actually carrying the operation of approval. This is really important. This is one of the most common issues we face with Odoo code. Another example, with now not a controller, but just a normal model method here. We have a get notification method, and pretty similarly to what we've seen earlier with the SQL injection, it starts with constructing a SQL query that has to be executed on the database. And if you look at it, you see that the developer here did not fall into the problem of SQL injection, and the parameters, the parameter partner ID is properly passed as an argument to the execute method on the query. However, there is another issue here. This method, as you may notice, is public because there is no leading underscore, which is the convention for making methods private and enforcing it within the framework. So this method can be called by anyone through RPC or RPC protocol. This means that we need to be sure nobody will be calling this method to obtain data that they're not entitled to. However, the problem is that we are using direct SQL queries over the database, and that bypasses all of the security. If you see the security as an onion, it's like we are slicing directly through the layers, and we are going to the core directly and bypassing all of the access control layers of the framework. So when we do that, the normal security model doesn't apply, and there's just no way the system will be able to know if the query is dangerous or not. So it falls on the developer to properly secure their code in this situation. What should you do here? One way of doing it would be to improve the security by making the method private, assuming that it can be private, otherwise we'll have more security to foresee. By making it private, we ensure that only other parts of the system and the business logic can call it, but it's not reachable by normal RPC and by attackers. And also, because we are going directly in the database with raw SQL code, we can include a specific check access right call in order to verify that whoever is calling this method also has read access to the model being queried. It may not be enough, and you may want to also enforce the record rules that are filtering the kind of output that you get from this method. So again, there may be additional security needed depending on what this query would actually be doing. Here is just a small example. But there are so many more examples of broken access control that you can find in Odoo code. This is one of the areas where you really want the knowledge of all these ways that the access control can be bypassed, and you want the mindset of looking for those problems and actively trying to protect these against attackers. A6, security misconfiguration. This one is pretty obvious in the name. It's whenever you have used a system that is not properly configured. Most of the time this happens because you have simply left the default parameters and they're unsafe. We have a very interesting deployment checklist that you may want to carry if you are to carry out if you are deploying Odoo. You want to go on odoo.com/documentation. There is a deployment guide, and as part of the deployment guide, we have a security part with a detailed checklist of all the things in terms of database, in terms of parameters of Odoo itself, in terms of security of the systems, of the operating system where you are deploying Odoo. So there's a good checklist that you want to check out there. And that will be advice specific to Odoo. Obviously, the problems of security misconfiguration are all over the place, from your network equipment to your Wi-Fi routers, your systems, your operating systems, your SSH access to your production systems, and so on and so forth. And by the way, again, in version 14, we have a small change here in the way we manage the default password for the database manager system, because we are so used to seeing Odoo installations publicly available on the internet, but with the default admin password for the database manager, making the database completely unprotected. We are going to force users to generate a random password now the first time they create a database. All right, moving on to the next worst case of security issues in the Odoo world, XSS. That's really the second one in the top 2 of Odoo issues that we see when we review code from Odoo developers. XSS stands for cross-site scripting, and is again a kind of injection. It actually is a subset of A1, if you want to put it this way. Its XSS means that another website or an external attacker is able to script your website, is able to trigger some logic in your website that you didn't put there. And typically this XSS will take place in the browser because that's where the logic of our application is being executed. So let's see a few cases, because this is really a very common issue. On the right here, we have an example of a case that we would name a stored XSS. It's one of the different kinds of XSS that we can find. You see a controller named index that is preparing some context and passing it to a template, what we call QWeb templates, for rendering a page. And this dictionary is being used, if you see on the right, or the bottom right here, and inserted into a script tag that will be output and sent back to the browser in order to define the session info dictionary that the JavaScript code will want to use during operation. What could be wrong here? The problem is that the developer has used the t-row construct in order to directly output whatever value it is passing it to the output being sent to the browser. So what if now the session info contains dangerous characters. This could happen because if you look on the top, the session info actually contains the username of a user. And let's say the user is an attacker, so here the name of the attacker. Let's say they made it a weird name with a closing script tag, then another script opening, and some payload there. The payload doesn't matter, but it's basically any JavaScript code that the attacker would want to execute in your web page, in the context of your page. Because of the T row here, nothing specific is done with the content of the name of the attacker, and it's directly sent back to the browser exactly how it was passed. So the result is visible here at the bottom, and we see that the script that is part of the name of the attacker is put into double quotes as part of the definition of a JavaScript variable. This looks okay, right? Because it's not part of the XML markup of the page. It's just within a JavaScript variable. Actually, that's how you may think of it, but that's not how the browser is going to see it, because browsers, they have very weird and complicated and multi-layered parsers with different contexts. And the first parser that actually runs is not the JavaScript parser, is the HTML parser that is going to look for these script tags. And when it does, what it's going to see is this. It's going to look at the opening script tag that was intentionally put there, and the closing tag it was going to match is the one that the attacker put there, even though it is part of a JavaScript variable. Remember, that parser at that time is not parsing JavaScript source yet. It's just looking at the structure of the document. And the second script tag that it's going to detect is the one that the attacker put there. So even though the first script tag may suddenly be corrupted and cause some issues, maybe some error message that will appear in the console of the browser with no big consequence, the other script that the attacker put there is going to be executed just fine, and it could lead to anything from data being stolen to changes performed on behalf of the user without them being able to notice. So there's a lot of problems that can be triggered with XSS. How would you go about fixing this one? Obviously, in this case, you don't want to be using trow, but you want to use the task directive that is designed for this kind of issue, and that will simply escape all of the dangerous characters that may trigger effect on the HTML markup. And the result is what you see here on the bottom left. Instead of having the normal tag and angle brackets that the attacker put there, they are converted in XML entities that will not execute anything, and we blocked the issue. This is a stored XSS because the data that the attacker put there, the payload, is stored in the database, and it's just waiting to be displayed for a visitor a victim that will be sent to the page that was prepared by the attacker. A variation of this attack is a reflected XSS, where instead of being stored in the database, the payload of the attack is passed as a parameter in the URL that the attacker is preparing and directly echoed back to the victim. Another very common kind of XSS is a DOM-based XSS, which in this case happens directly in the browser as part of the dynamic business logic of the application. So it's not prepared on the server side and sent back directly as is to the client side. It's triggered during the normal execution of the client side logic. Here we have an example of a JavaScript method on the right here that looks for a specific element in the document that is in the browser and wants to, in this case, it is a product, and we want to display below the product some attributes that the user, the customer, has specified before. So the way the method goes about it is looking for the element in the page that displays this, then taking the HTML source, as you see, it calls HTML method and puts that in a desk variable. That's going to alter that HTML source, and at the end of the method is going to reinsert the modified version of the HTML source of that document after having inserted the attribute value and the custom value that the customer has specified. The problem with this approach is that we are mixing two things. We are mixing text and we are mixing HTML. These are two separate domains and we should never mix them because otherwise XSS issues occur. In this case, the attribute name that the customer has input are text values, and we are directly inserting them in the HTML source of the initial product description that was on the page. By doing so, we are creating a problem because the text will become markup even though it was not intended to be. So again, those script tags that the attacker may put there will become executable as a result. The way we want to avoid that issue would be by making a conversion between text and HTML and converting through the escape mechanism the text into proper markup that is not executable. That's one way of doing it, and in this case you would be using the _.escape method to carry that conversion. However, this one is not ideal because we are still mixing a little bit HTML and text, and we want to avoid that as much as possible. So a better way of fixing this is to not even mix them and only work in the text domain. And there is an example here where you would be constructing the nodes and setting their text attributes directly, and there is no escaping necessary because we never left the text domain, we only manipulated text here. So that's the best way to fight against this. These were two examples of XSS, but in reality there are many more ways to trigger XSS vulnerability. We've seen string formatting, we've seen vulnerable templates with the t-row construct that you should really be careful about. You only want to use it when you know that the value is safe and trusted and sanitized. But there are problems that you can have with the eval method when you are using it to evaluate untrusted data and untrusted data. We're going to see about this in a second. You have vulnerable libraries that may not be prepared to properly handle HTML and text in the way you would expect. There are uploaded files that could be used to trigger some behavior in the browser, and even links could be a way of injecting script that you don't want to have in your website. But we've been long over XSS. Let's go and move on to the next one, 8, insecure deserialization. Well, we were talking about using eval in a dangerous way. Developers sometimes try to use eval as a way to convert a serialized version of a data structure and transforming it back into the in-memory data structure, such as a dictionary that you want to convert back into a real dictionary object. Eval is not the right way to go about that, because eval would also execute any arbitrary code that would be in the data structure and that the attacker may have put there. So in that case, you want to use things like JSON as a format for serializing and deserializing data. Again, in this case, the framework does a lot of the job for you and tries to protect against all of these serialization issues. You just have to be careful if you are doing your own serialization and deserialization, especially as it's not just arbitrary code execution with eval. It could be something more subtle, such as you have constructed a token with the name of the user that is carrying the operation, and you're sending it by email, and you expect the email to be clicked, the link to be clicked, and the token to come back later on in the flow. But you didn't foresee that maybe an attacker would alter the token and would modify the ID of the user that was part of the token. And you may think later that another user is carrying the operation, whereas it was actually an attacker spoofing another user. So in that case, you want to sign your data structure to make it resistant to this kind of tampering. Otherwise, the framework does everything for you here as well. We have A9, vulnerable components. I'm not going to go over a lot of details there, because vulnerable components is basically when you are using a library that has known issues there. We are using libraries in the Python side for instance, the Pillow library for image processing. On the client side as well, in JavaScript, we are using all sorts of libraries like Bootstrap, jQuery, some very well-known libraries. And all of these that I've just mentioned, they suffer from a lot of well-known security issues. And if you are using your own libraries, you may have the same issue. So you have to take precaution. In our case, the framework, in terms of image processing, we disable all of the features in the Pillow library that contain the security issues. On the JavaScript side, we study all of the CVEs that are published for these security issues in these libraries, and we verify that they are not exploitable through Odoo. The problem with these libraries is that they don't maintain very well the old versions of the libraries, and with Odoo we have to live for a long time with the 3 versions, the LTS versions, so we have to support this library for a long time, and they don't provide the fixes. So we will usually do them if there is a need, because the issue is exploitable through Odoo. And the last one is insufficient logging. It may look less like a security issue because it's not directly something that the attacker can use to affect your system. But it can be very much of a problem if it's too late and you suffered from an attack and you are unable to determine the extent of the attack or the source of the attack, and you have too few data to go on and secure your system and determine the damage. So that's why there is never enough logging. You always want to be sure to log explicitly sensitive operations. The system, Odoo, is doing some of that logging for you. Typically, authentication, login, logout, reset of password are logged in the server logs, including the person doing it, and when it's important, the IP address of origin of the request. But there are also tools that you can use. Here we have an example of a decorator, a Python decorator that is used in a few places to make sure that the user executing the operation is an administrator. And in that case, we log that this administrator did that, but also blocking access if the user is not an administrator. So that's one example of a tool that you may want to use. But basically, do the logging however you want, but be sure to log all the security sensitive operations that your code may be carrying. Oh, and I was talking about a checklist that you can use to review your code before merging it, before shipping your feature. Here it is. I've included the 6 main areas that are relevant for a typical Odoo development. It covers most of the top 10 issues that are part of the OWASP top 10. But really remember that this is not enough. Just looking at these different items and making sure that they are properly covered is not enough to have a secure system. What you really need is to have someone who develops the knowledge and the mindset of the team in terms of security. You want to choose someone who is into security, who likes to break systems, to tinker with things, to see how they can be broken. If you have that person in your team, it's really great to have them work on security, improving their knowledge and disseminating that knowledge to the team, and looking with a critical eye on every feature, looking for ways to break it, because that's the only way you can fight against attackers that would be doing the same. You want to be early, and you want to do that before they think of the issue, so that you can close it. All right, thank you, and we'll be seeing if there is any question. I will be happy to answer them. I've been very quick over all of these topics because there was a lot of ground to cover, so I assume there will be questions over this issue. Thank you.
Welcome. We're now ready to answer some questions. So I'll start right away with this question from Mashuk. what are the possible security threats to an Odoo database if we're using a rather older version such as Odoo 10 or Odoo 10 Community Edition?
Well, that's a good question, especially as we are. Can you hear me? Wait, we have small issue with the mic. Is it okay? Tu peux te rapprocher, est-ce que can you check, or I can talk in the.
Wait.
Is it working? Is it better? Can you hear me? No. Let's see.
It's off. Wait. Should be fine now?
Can you hear me now? Okay, good. Sorry. Sorry, small technical issue. So it's a good question, especially because version 14 is out, which means that because we keep only 3 LTS versions supported, we are going to end the support for version 11. And so, of course, version 10 is out of support since the previous version, 2019. So what happens in terms of security fixes, we only fix the LTS versions that are still supported. So it is true that Odoo 10 Community Edition may have some vulnerabilities that have not been fixed. In fact, we haven't released many bug fixes for version 11 since the deprecation of version 10, so there are not actually lots of issues, but it is definitely something that you want to consider. Also, one thing about Community Edition versus Enterprise Edition, there's no difference. We support the LTS versions similarly, whether it is Enterprise or Community. And of course, the difference is that the Enterprise Edition comes with some specific service where we are going to notify customers when there is a security vulnerability that they need to patch a little bit in advance before making it public on our GitHub repository and disclosing it on our mailing list. So if you are only using the Community Edition, you may want to follow our mailing lists and watch our GitHub repository to learn about security issues that will be released. So that's, I think, something you want to keep in mind.
Okay, thanks. Here I have a question from Summer about data encryption. He says there are some secrets data such as SMTP credentials and third-party integrating credentials. What about storing them encrypted, I guess? I'm not sure about the question.
In the database. I guess it's something that can bug you if you notice that you are storing secrets in the database and you need to keep them in plain text. Mm-hmm. Unfortunately, when you are integrating with an external system such as a mail service, you need to authenticate. So you cannot one-way hash the secret the way we do with passwords, because you need to know actually the plain text of the secret so that the application can authenticate on the service. So we can't hash the secrets in the way we do for user passwords, because we need to be able to read them. So if we simply encrypted them with some reversible encryption mechanism, it wouldn't do much good, because in case the database was stolen, it would still be possible to reverse the encryption. Even if we try to store the encryption key in a different place, usually if your database or your application is taken over, you won't be able to protect against that. So we have to do different things. One option is to use different protocols that are not based on plain text passwords, but on the exchange of keys. Or you can use one of the alternative to passwords that many services offer, such as API keys. Like if you're authenticating to a Gmail service, you can on Gmail enable what they call, I think now, application passwords, app keys or app passwords, which are basically alternative to your password, that are kind of long passwords that are only used for a single application, and you can revoke them and reset them regularly if you need. So maybe that's one option, but there is no magic to storing these secrets encrypted and safe in our database if the application needs to read them in order to authenticate to an external service. So I hope that answers the question a little bit.
Yep. Here we just got another interesting question. Ruchir, I guess. Any alternative for sudo? Just to bypass a few models, record rules, access rights only?
So the question would be if there is
the question is about, okay, in places where we use sudo to actually bypass security checks because somehow we need to, what are alternatives? Are there alternatives?
I guess you don't have many alternatives. And if you want to be sure that you are keeping the scope of your elevated privilege region very constrained, you can use sudo for a very small part of the code and make sure that you stop using the sudo environment as soon as possible. Of course, there are alternatives such as directly, slicing the onion and attacking the database with direct SQL access, for instance. So in that case, you don't need sudo, but you're doing something that is as dangerous. Basically, it's not propagating as much as a sudo environment if you are not careful. But that would be still something very dangerous, and you always need to be very careful when you are using one of these techniques. That's what code reviews is very helpful for, right?
Thank you, Olivier. If you have more questions, I think you might be available, maybe in the community room of OWASP.
Right. If you want to reach me, or if you want to chat about security issues, I'm hanging out sometimes in the OWASP meeting room, or the community room, where you can join us. And if I'm not there, you can talk to the guys and ask your questions, and they may just call me they summon me to help and discuss these issues. And of course, the guys there are also very knowledgeable about security in Odoo. Well, thank you for attending this presentation, and I guess I'll see you around in the community rooms during these days.